Okay, let's talk about chemical buffers. They're basically the silent heroes keeping things stable in our world. Ever wonder why drinking lemonade doesn't just throw your whole body's chemistry out of whack? Well, see, if you add acid to pure water, the pH drops like a rock. But in a buffered solution, barely a change. That kind of instability is a huge problem. It can wreck experiments and, it's just not compatible with life. And that's where buffers come in. Their whole job is to resist those pH changes. So what's the secret sauce? A buffer is always a team. A weak acid and its partner, the conjugate base. You can think of them as a kind of chemical sponge, soaking up extra protons when needed. Here's how the team works. The base part handles any added acid, and the acid part handles any added base. Basically, the buffer components jump in and react first. They're like bodyguards for the solution's pH. And this whole relationship is actually described by a pretty neat equation called the Henderson-Hasselbalch. Okay, let's get practical. You've probably seen a pH meter, right? Well, they're useless without buffers. Yeah, to get an accurate reading, you have to calibrate it with solutions that have a super stable known pH. And that means using different buffers. Usually one that's neutral, one that's acidic, and one that's alkaline. Buffers are also vital in labs for protecting things like DNA and keeping cell cultures happy and alive. Which brings us back to our own bodies. Your blood is kept at a very precise 7.4 pH. If it goes just a little bit off, say below 7.1 or above 7.8, well, that can actually be fatal.
So how do we manage it? With our very own built-in buffer, the carbonic acid system in our blood.
And it's not just your blood. Different parts of your body all have their own specific buffered pH levels. It really makes you wonder, what other invisible systems are out there just quietly keeping our world in balance?